Okay, let's talk about odds ratios. So, one of the key elements of logistic regression is understanding an odds ratio. And so, a bit about odds. The odds tell you how likely an event is. So, for example, if we said there was a 60% chance of rain today, what's the probability that it will rain? The probability is going to be 0.6, or corresponding exactly to that 60%. And what's the probability that it won't rain? It's just going to be 1 minus that, and so 0.4. What are the odds that it will rain? The odds are 3 to 2, or sometimes you write this like this, 3 colon 2, or we could divide that. And so that 3 divided by 2, or that 0.6 divided by 0.4 is going to be equal to 1.5. And so the odds are 1.5. So transforming the logs, how do you undo a log in base E? And so you use E. So for example, E to the log of 10 is equal to 10. E to the log of 1,283 is equal to 1,283. E to the log of x is equal to x. Okay, so how would you get odds from the log odds? E to the log odds is equal to the odds. And so hopefully this is going to now sort of ring in why we're getting at this, because as I mentioned in the previous lecture, when we're dealing with either the logit scale or the log odds scale, we often want to turn those log odds into odds, because odds ratios are sort of maybe a little bit easier to interpret than a log odds. Okay, so transforming the odds. So the odds are equal to pi, which I'm saying is the probability, divided by 1 minus pi. And solving for that pi, we can say that probability is equal to the odds over 1 plus the odds. So we can go between odds and probabilities, and we can go from probabilities back to odds. So if we're plugging in that e to the log odds is equal to the odds, then we know that the probability, pi, is equal to e to the log odds over 1 plus e to the log odds. And now this should look really familiar, because this is that logistic form that we had just shown in the previous lecture. And plugging in log odds, we get that the log of the odds is equal to beta 0 plus beta 1 x. And so this is getting it into that logit or log odds form. And so that pi is going to be equal to e to the beta 0 plus beta 1x over 1 plus e to the beta 0 plus beta 1x. So the logistic model, there are two forms. The logit form, which is the log of that probability over 1 minus the probability, which is equal to beta 0 plus beta 1x, and so this gets it into that linear form. Or there's the probability form. So that pi is equal to e to the beta 0 plus beta 1x over 1 plus e to the beta 0 beta 1x. And again, when I'm saying pi here, this is, in the previous slide I called this p of x. This is the probability that y equals 1 given x. So this is not pi like 3.14, this is just probability. So this is the kind of table for transforming. We can go from a probability to the odds to the log odds. So a probability, if a probability is defined as pi, the odds are going to be pi over 1 minus pi, and the log odds are just going to be the log of that. And we can also go the opposite way. So if we have the log odds, L, we can get to the odds by exponentiating it, so taking e to the L. And we can get back to a probability by taking e to the L over 1 plus e to the L. And that will get us back to our original probability pi. So, two forms of logistic regression. We've got the log odds form and the probability form. The probability of the outcome equals yes, or the outcome equals 1 given x. Okay, so now let's talk about odds ratios. So, a study investigated whether a handheld device that sends a magnetic pulse into a person's head might be an effective treatment for migraine headaches. And so researchers recruited 200 subjects who suffered from migraines, and they randomly assigned them to either receive this TMS, this transcranial magnetic stimulation, so this is some treatment, or a placebo. And subjects were instructed to apply the device at onset of migraine symptoms and then assess how they feel 2 hours later, either pain-free or not pain-free. So what is the explanatory variable here, or the predictor? It's going to be treatment or placebo. And what type of variable is this? It's going to be binary. It's either going to be a value for treatment or a value for placebo. And then the outcome variable, it's going to be pain-free or not pain-free. And again, this is a binary variable as well. Okay, so we can summarize all of the information that I just gave you in a 2x2 table. So on the top of this table, I have the X variable, the predictor, TMS, the treatment or placebo. And on the on this side here, on the side, I've got the outcome, pain-free 2 hours later or not pain-free. And we can compare these results using odds. And so what are the odds of being pain-free for the placebo group? So that's going to be 22 divided by 100. So that's the probability of being pain-free, given that you're in the placebo group, 22 divided by 100. And then if you remember, the odds are, it's the probability divided by 1 minus the probability. And so the probability of being not pain-free in the placebo group would be 78 divided by 100. So 22 over 100 divided by 78 over 100, which is equal to 22 over 78, which is equal to 0.282. And what are the odds of being pain-free for the treatment group? And so that's going to be 39 divided by 100 divided by 61 divided by 100, which is the same as just 39 divided by 61. And so that's going to be 0.639. Now, comparing these odds, what can we conclude? We can conclude that TMS, or the treatment, increases the likelihood of success because those in the treatment group here have a higher odds of being pain-free than those in the control group. And we can actually summarize this relationship with what's known as an odds ratio, or the ratio of the two odds. So we can look at that odds ratio of 39 over 61 divided by 22 over 78, or that 0.693 divided by 0.282. So the odds of the success in the treatment group divided by the odds of success in the control group, and that's equal to 2.27. So that means that the odds of being pain-free were 2.27 times higher with TMS, so with the treatment, than with the placebo. What if we wanted to calculate this in terms of not pain-free, with pain-free as the referent? So then we would just flip this, and so instead of doing 39 over 61, we do 61 over 39. Instead of doing 22 over 78, we do 78 over 22, and we end up with 0.441. So the odds of being still in pain, so not pain-free, for the TMS group are 0.441 times the odds of being in pain for the placebo group. Okay, what changed here? So now I've flipped it, so the values end up being the same in the end, the 2.27, but now I'm doing 78 over 22 divided by 61 over 39. And so this is going to be the odds of still being in pain for the placebo group compared to the odds of still being in pain for the TMS group. So now I've flipped both the referent category for the outcome and the referent category for the exposure. And so what this demonstrates is that we can sort of flip around what our referent categories are, and we get slightly different answers, so we need to interpret them in the context of what the referent category is. In general, it's more natural to interpret odds ratios greater than 1, and so you can always flip the referent to do so. And so if you flip which one is the referent category, that can be helpful. Although sometimes in the context, there's a referent that's more natural, and you'll end up with an odds ratio less than 1, which is fine as long as you interpret it correctly. Okay, so let's pause for a quick application exercise. So 5,000 women were enrolled in a study and were randomly assigned to receive either letrozole or placebo. And the primary response variable of interest was either disease-free survival or not, so death or disease or no death or disease. And so here I've got a 2x2 table describing the relationship between the explanatory variable, or the predictor, the treatment, and the outcome. I want you to calculate the odds ratio of death or disease in the placebo group versus treatment group, and then calculate the odds ratio of no death or disease in the treatment group versus placebo group, and then calculate the odds ratio of death or disease in the treatment group versus placebo group. And so go ahead and open that RMD file, open a file in RStudio Pro, and put these 3 values into that file, and then leave it open because the future lecture we're going to build on this a little bit.